In 1 second, the planet's rotation stops. No warning, no slow fade, just a hard, brutal halt. And what follows is not a movie. It's physics doing exactly what it always does. You clicked because the idea feels wrong in a very specific way. What actually happens if Earth just stops? Over the next 8 minutes, I'll walk you through the immediate collapse, the weeks that follow, and the only narrow zone where life could possibly cling on. This is science, clear, steady, and unflinching. Let's begin.
Let's go!
What's going on, everyone? I'm Rezvan, and welcome to the channel where we dive into the absolute coolest and most mind-blowing facts out there. Have a specific fact or myth you want me to bust in the next video? Drop it in the comments below and I might just feature it. And before we start, make sure to smash that like button and subscribe so you never miss out. Let's get into it. Right now, everything on Earth is moving with the planet. At the equator, that motion is about 1,670 kilometers per hour. You don't feel it because the ground and the air move with you. If the planet stops, you don't. Inertia keeps everything, people, cars, trees, the surface of the oceans, moving at the same speed the planet had a millisecond before. The first and most lethal effect happens in those first seconds. Objects and people outside are hurled eastward at enormous speeds. Buildings face lateral forces they were never engineered to handle. Concrete is extremely strong under vertical loads. Sideways shear is another story. Institutions shear off, roads rip apart, and the urban landscape becomes a hazard field of collapsing debris. The atmosphere doesn't stop either. The air keeps moving, creating supersonic winds and shock fronts that race across continental distances. These winds carry debris, water, and sand, turning open spaces into lethal high-speed projectiles. Survival in many regions depends less on whether your house is standing, and more on whether your shelter can withstand the pressure of that moving sky. If you're deep underground in a purpose-built facility, your chances improve. If you're in a typical above-ground building, they do not. Basic infrastructure, power grids, communication networks, transportation, suffers catastrophic damage in minutes. The world becomes a noisy, chaotic place of collapsing systems and failing supports. After the initial seconds and minutes, the planet moves into a new phase. The oceans begin to rearrange. Earth's rotation creates an equatorial bulge in both land and sea. That bulge is supported by centrifugal force. Remove rotation, and the bulge collapses. Trillions of cubic meters of seawater begin to flow toward the poles. This is not a single tsunami. It is a global redistribution of water. Coastlines are not merely flooded, they are permanently reshaped. Entire coastal plains are swept inland by waves that can reach heights measured in kilometers. Ports, cities, and low-lying nations face immediate inundation. Freshwater sources near coasts are contaminated with salt. The first days and weeks are dominated by moving water, relentless, enormous, and unstoppable. As the waters settle into new basins, the planet reveals a more patient, slow-moving catastrophe: thermal collapse. Without rotation, one hemisphere faces the sun continuously, while the other remains in shadow. Daytime stretches into months. Night stretches into months. The planet no longer cycles through 24-hour days. The sun-facing hemisphere heats without pause. Temperatures climb dramatically. Surface water evaporates faster. Weather systems that depend on rotation collapse or reorganize into strange, extreme patterns. The air over the hot side becomes thick and unstable. Ocean surfaces warm, and in shallow regions, the heating is rapid enough to stress marine ecosystems beyond recovery. On the dark side, the opposite happens. Deprived of sunlight for months, temperatures plunge. Oceans near the dark pole begin to freeze. Atmospheric circulation slows. The dark hemisphere becomes an expanding, solid cold, where ice and permafrost replace what used to be temperate zones. Plants and animals that depend on daily cycles or seasonal cues fail to adapt. Agriculture collapses across latitudes that once produced food reliably. Between these two extremes, a narrow strip remains, the Terminator line. This is the twilight band that separates day from night. Here, temperatures are more moderate. Liquid water can exist. Photosynthesis is possible. In the immediate aftermath, this twilight corridor becomes the only place with a realistic chance of supporting human life at scale. But survivable is not the same as comfortable. Life along the Terminator is precarious. Fresh water must be conserved and recycled. Food production must be mobile and highly efficient. Energy systems must adapt to low-angle sunlight and long periods without direct solar input. Technology, if available, is repurposed for survival. Desalination plants, compact greenhouses, thermally insulated shelters, and systems for catching and storing what little precipitation occurs. There is another crucial complication. Earth continues to orbit the Sun. Because the planet still moves around the Sun, even if it no longer spins on its axis, the Terminator line slowly migrates. The twilight band is not fixed. It shifts around the globe over the course of the year, forcing any surviving communities to move with it. Long-term survival becomes a matter of mobility and logistics. Settlements must be portable. Agriculture must be transient or replicated along the route. Resource planning becomes a form of perpetual migration. This new lifestyle would demand unprecedented cooperation and coordination. It would require systems built for movement, modular habitats, transport convoys, mobile water purification, and a social order that prizes adaptability over territoriality. Competition for resources would be intense. Societies that organize supply chains and maintain mobility would have a significant advantage over isolated groups trying to hold fixed territory. The biological consequences are stark. Many species, plants and animals alike, are adapted to daily or seasonal cycles. Extended daylight or darkness disrupts reproductive cycles, migration patterns, and food chains. Some organisms may find refuge in microclimates or underground environments, but biodiversity will collapse in many regions. The survivors, human and non-human, are the ones that can change quickly, either through behavior, technology, or both. There are secondary, long-term effects to consider as well. The atmosphere's composition could change as ecosystems fail. Carbon dioxide and methane dynamics shift. Aerosols from fires or dust storms could affect incoming solar radiation. The magnetic field, which is generated by fluid motions in Earth's outer core, is not immediately affected by surface rotation stopping. But longer-term geophysical processes could alter magnetic stability. These are complex, slow-moving processes that would unfold over months and years, and would further complicate recovery. So, what does all this mean for an individual watching this video? First, the chances of surviving the initial stop in most populated, open regions are very low. The most realistic near-term survival strategy is deep, engineered shelter, designed to withstand both structural shear and the pressure of moving air. After the first months, the practical strategy shifts. Mobility, efficient resource use, and access to the Terminator line become critical. This scenario is catastrophic, but it also helps us appreciate the delicate balance that makes Earth hospitable. The physics at play are unforgiving, but the thought experiment is useful because it forces us to think about infrastructure, energy resilience, and cooperative survival strategies in extreme conditions. If you found this explanation useful, subscribe for more clear, physics-based breakdowns. Leave a question in the comments, and I will cover the most requested follow-up. Stay curious, and thanks for watching.